right, calcularians, time to get started on proving how to find the derivative of a square root or the derivative of a rational function like 1 over x. So we saw a couple examples previously where g of x was 1 over x. And to find the derivative, we rewrote 1 over x as x to the negative 1. So g prime of x, the negative 1 comes down, x to the negative 1 minus 1, negative 1, x to the negative second power. Now, a second example we saw was a square root. In the square root, we rewrote as x to the 1/2 power. So taking the derivative using our shortcut rule, we have 1/2 x to the 1/2 minus 1, 1/2 x to the negative 1/2 power. Now in both of these functions, we end up with negative 1 over x squared and a 1 over 2 times the square root of x. So given a radical function, the derivative ends up being something rational with the square root in the denominator. And if you didn't follow that, think of this 1/2 x to the negative 1/2 can be rewritten as 1 over 2x to the 1/2. Negative exponents, I had the x to the negative 1/2 join the denominator and then rewrote it as a radical. So what I want to do today is prove that using the definition that we use to go from a function to its derivative. So this one's going to be a little bit longer, I think, so bear with me, take your time, but here I have g of x is the square root of 13x. Now, I'm throwing a curve at you here because the 13 is in front of the x. We actually have a coefficient here, and I want you to see if we have that coefficient, how that affects the derivative. So, just up here in the corner, when g of x was just the square root of x, g prime of x turns out to be 1 over 2 times the square root of x. Now, hopefully you're seeing that 2 root x. So there's a 13 here. When there is the 13 there, we end up with this 13 in the numerator. So some things to be noticing and thinking about. So I'm going to prove how g of x, when defined as the square root of 13x, the derivative is 13 over 2 root 13x. And anytime you're asked to prove something, we have to go back to our limit. We will have the square root of 13x plus h minus the square root of 13x all over x plus h minus x. Okay, now we're going to do some math magic. This can be rewritten as 13x plus 13h minus the square root of 13x all over h. So I distributed the 13 that was underneath the radical here to get the square root of 13x plus 13h minus the square root of 13x all over h. At this stage in the game, if I was to take the limit and throw in h as 0, this term would go away. The h would be 0, and I would be the square root of 13x minus the square root of 13x, which will give me 0 all over 0. So I know I need to do more work. Now, in order to make this happen, in the past, we saw a polynomial in which we FOILed out and we simplified. So I happen to have a previous example right here. When I was doing this, when I was proving, I would FOIL out and look to see things cancel. With a radical, things get pretty radical and pretty crazy. They get pretty shark crazy. Scary sharks. Oh boy. But it's okay. We're here to get you through that. This move is going to sound bizarre to you, but I'm going to tell you what it is. To get out of this trouble that I'm in, I'm going to actually multiply by the conjugate. This move to you all is going to seem so bizarre and crazy. And you're asking yourself why. In perhaps you remember a long time ago, if you had a square root in the denominator, your teacher would get really mad at you and tell you to multiply by the conjugate so that your radical is no longer in the denominator. Now we're going to do this trick where we multiply by the conjugate in order to get the radical out of the numerator into the denominator, and then we get to do some simplification. So bear with me and just follow along that this numerator, the 13x plus 13h minus 13x square roots, notice I'm going to multiply by the plus. And I'm multiplying my fraction both on top and bottom. By doing so, all I'm doing is multiplying by 1. This thing is just a 1. So, I've got this equals the limit as h goes to 0. Now when you multiply the square root of 13x plus 13h times the square root of 13x plus 13h, the radicals knock out. So I'm left with 13x plus 13h. Now, the square root of 13x times this guy, then notice I have the square root of 13x times this guy, and given that they're opposite signs, this is where this move is pretty awesome because the middle terms are going to cancel out. So I don't have to worry about multiplying this by this, these two terms, because they're both the same term with opposite signs, so they will knock each other out. Then, continuing to FOIL, I multiply a negative root 13x times a positive root 13x. So the root 13x times root 13x, the radical goes away and I'm left with 13x. And since it's a negative times a positive, it's a minus. This is all over, I've got my h from before, times the square root of 13x plus 13h plus the square root of 13x. Now, we're at a similar point where things are going to start canceling out. 13x minus 13x. So I have the limit as h goes to 0, 13h all over h times the square root of 13x plus 13h plus the square root of 13x. Now, more canceling, right? H on top, h on bottom, that cancels out. So now I'm left with the limit as h goes to 0, 13 all over the square root of 13x plus 13h plus the square root of 13x. Now if I let h go to 0, this thing will go away, and I have 13 over the square root of 13x plus the square root of 13x. Notice I took my limit as h goes to 0, so I don't have to write it here. The square root of 13x plus the square root of 13x. Dun, 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 dun. That's just 2 times the square root of 13x. Boom. 13 over 2 times the square root of 13x. Here is my g prime of x. Now, I'm going to stop there and let you sit and think about it. And we'll tie some things in together in a minute. Boom.